It really feels like AI is moving at an impossible speed, doesn't it? One minute we're looking at these basic text generators, and the next we have systems that can tackle complex, multi-hour projects pretty much all on their own. And this blinding pace creates a huge challenge for us. Right, how do you even begin to measure a revolution while you're in the middle of it? I mean, when the ground is literally shifting under your feet, your old tools just don't work anymore. And in the world of AI, our traditional measuring sticks, our benchmarks, they're really starting to crack under the strain. And this is the perfect way to think about it. Trying to evaluate today's AI with old benchmarks is kind of like using a ruler to measure a rocket ship. A lot of these older tests, they focus on these weird artificial tasks that don't really tell you much about real-world use. Or even worse, the AIs get so good so fast that the benchmarks just saturate. Everybody gets 100%, and you completely miss the real story of how powerful these things are actually becoming. So to fix this problem, researchers at METR, that's the Model Evaluation and Threat Research Group, came up with a totally groundbreaking new yardstick. And in this explainer, we're going to break down exactly how they're trying to measure what AI can really do. Okay, so here's the core idea. It's called the 50% task completion time horizon. Yeah, I know it's a bit of a mouthful, but the concept itself is beautifully simple. It just asks, what is the longest task an AI can successfully finish about half the time? The really crucial part here is that the task's length isn't measured in computer clock cycles. It's measured in the time it would take a skilled human to do it. And that grounds AI capability in something we can all just intuitively get, our own effort. So how did they actually put this idea into practice? Well, you can see their methodology right here. It's a pretty straightforward three-step process. First, they built this massive, diverse collection of real-world tasks. Then, for each task, they measured two things: how long it took skilled humans to do it, and of course, how often the AI succeeded. And finally, they crunched all that data to pinpoint each AI model's 50% time horizon. And when I say a diverse range of tasks, I really mean it. We're talking about everything from a simple 3-second multiple-choice question all the way up to an incredibly complex 8-hour coding project that would take an expert human an entire workday to finish. It's this huge variety that makes the final metrics so robust and so meaningful. Okay, so they built the yardstick, they gathered all the data. So what did they find? What happened when they applied this new metric to AI models, stretching all the way back to 2019? Well, to put it simply, the results were staggering. Once they plotted the capabilities of these models over time, a crystal clear and kind of shocking pattern emerged. And this right here, this is the key graph from the entire paper. Let's just take a second and really soak this in. Along the bottom, you've got the model's release date. And on the vertical axis, you see the length of the task the AI can handle. Now pay close attention to that vertical axis. It's a logarithmic scale. And that's super important, because a straight line on a log scale means you're looking at consistent, relentless, exponential growth. The trend is it's unmistakable. From GPT-2, which could barely handle a 2-second task, all the way up to Claude 3.7 Sonnet, which is knocking on the door of the 1-hour mark. So, when you actually calculate the slope of that line, you get to the most crucial finding of all. On average, the task completion time horizon of frontier AI models has been doubling every 7 months. Just let that sink in for a second. The complexity of tasks these systems can reliably handle has literally doubled every 7 months. And this isn't just some statistical trick with the trend line. I mean, if you look at each model individually, you see the exact same story playing out. With every new generation, that 50% success point, that's the red dotted line, it just marches steadily to the right, deeper and deeper into longer, more complex tasks. It goes from just 2 seconds for GPT-2 up to 8 minutes for GPT-4, and now, with the latest models, it's pushing close to an hour. Okay, so being able to do something half the time is pretty impressive, but what about reliability? What can these systems do consistently, day in and day out? This is an absolutely crucial distinction, separating what an AI can do from what it can do reliably. So the researchers reran all the numbers, but this time they looked for an 80% success rate. And what's really fascinating here is that the doubling trend, it holds. The rate of improvement is almost exactly the same. But just look at that gap. The absolute capability is about 5 times lower. So for example, Claude 3.7 Sonnet 80% horizon is around 15 minutes, not the nearly 1 hour it can do at 50%. This really highlights this massive gap between peak performance and what you can actually count on. So this consistent exponential trend is so powerful that it lets us do something pretty remarkable. We can actually build a forecast. We can ask,
Where is all of this taking us? So what happens if you just take that 7-month doubling trend and you draw the line out into the future? Where does it actually lead? I mean, what kind of insane capability does it predict we're going to see? And maybe more importantly, when?
To answer that, the researchers defined this huge milestone that they call 1-month AI. Now, what is that? It's a system that can autonomously handle a project that would take a skilled human an entire month of full-time work. We're talking 167 hours. This isn't just the next small step. This would be a truly transformative leap. An AI that can manage a month-long project could potentially automate huge chunks of complex intellectual labor.
And here's the forecast. If, and this is a big if, but if this trend continues to hold, their extrapolation suggests we could see this 1-month AI capability arrive sometime between late 2028 and early 2031. Now, this chart shows all the uncertainty around that, but the central estimate lands it squarely within the next 5 years.
But, before we get too carried away with that forecast, we have to remember something really important. The real world is messy. Projections are not promises. And a benchmark, even a really good one like this, is still just a simplification of reality. The researchers knew this, of course, so they actually measured it. They scored all of their tasks based on 16 different messiness factors. Things like, unclear feedback or constantly changing environment. And this chart shows a really clear pattern. The messier a task gets, the worse the AI does. But, and this is the really critical part, they found the rate of improvement over time was basically the same for both the clean and the messy tasks. So the AIs are getting better at handling the mess at that same exponential pace.
So what is actually getting better under the hood to drive all this growth? Well, by actually digging into the AI's attempts, the researchers pinpointed a few key things. The models are showing way better logical reasoning, they're becoming much more reliable at using tools like code interpreters, and maybe most importantly, they're getting so much better at adapting when they make a mistake, instead of just getting stuck in a loop repeating the same failed action over and over again.
Which really just leaves us with this final, incredibly powerful question. We now have a clear, empirically measured exponential trend in a metric that's tied directly to real-world, economically valuable work. So, if this capability really does continue to double every 7 months, what exactly are we building? And are we remotely ready for it?